The James Webb Space Telescope, humanity's most powerful eye in the sky, has made a discovery that could one day rewrite our place in the universe. Recent findings suggest the possibility of human-like or intelligent activity light years away from Earth. For centuries, we've looked up at the stars and wondered if we're truly alone. That question isn't just the domain of scientists or science fiction writers. It's a universal mystery that has echoed through the minds of dreamers, thinkers, and stargazers since ancient times. And now, with the Webb telescope peering farther and clearer than any instrument before it, we're closer than ever to finding out whether the universe is home only to us, or to others as well. The search for extraterrestrial life isn't a new curiosity. It's as old as civilization itself. From the moment our ancestors first mapped the stars, humans have been consumed with the desire to understand what lies beyond the blue sky. Ancient cultures carved their questions into stone, and philosophers pondered the heavens as a mirror to the soul. In more modern times, this quest gave birth to thousands of books, theories, movies, and movements. It's not just about life on other planets. It's about the very nature of life itself and our role in the cosmic story. But today, that age-old quest is no longer limited to myth or speculation. With the advent of technologies like the James Webb Space Telescope, our tools are finally beginning to match our imagination. Back in 2021, astronomers proposed an intriguing thought experiment. Could our telescopes detect artificial light, such as city lights or power grids, on planets orbiting distant stars? Proxima B, an exoplanet just over 4 light-years away, was chosen as a likely candidate. It orbits Proxima Centauri, the closest known star to our own Sun, and resides in what's known as the habitable zone, where temperatures might be just right for liquid water, and perhaps life, to exist. Proxima B is believed to be tidally locked, much like how our moon always shows one face to Earth. One side of the planet may always bask in the light of its star, while the other side remains in perpetual darkness. That led scientists to wonder if an advanced civilization lived there. Could they use enormous solar farms to capture energy from the day side and transmit it to the night side? Could such a feat leave behind a detectable trace, a signature of intelligent life? One scientific paper, co-authored by the physicist Manasvi Lingam, suggested it might be possible. By covering large portions of the planet in solar panels made from advanced materials like photovoltaic cells, the civilization could generate electricity and even artificial light that our most powerful telescopes might detect, if we knew what to look for. And now, with the James Webb Space Telescope fully operational since 2022, humanity has its most promising chance yet to catch a glimpse of those clues. The JWST isn't just another telescope, it's a generational leap forward. With unmatched sensitivity, in the infrared spectrum, it can peer through cosmic dust, reveal the birthplaces of stars, and analyze the chemical makeup of distant atmospheres. It's already given us stunning images of galaxies formed shortly after the Big Bang, and it's probing planets light-years away for the building blocks of life. Thanks to this groundbreaking tool, we might soon confirm whether Proxima B, or another distant world, shows signs of artificial illumination. If true, such a discovery would mark the greatest scientific breakthrough since Copernicus moved Earth from the center of the universe. But before we let our imaginations run too far ahead, it's important to appreciate how extraordinary this feat of observation truly is. Throughout human history, our greatest thinkers have wrestled with questions that defy easy answers. Why are we here? Are we unique? Are we alone? These questions once belonged to the realm of religion, poetry, and philosophy. But in the modern era, thanks to exponential technological progress, we are now pursuing answers with cold instruments and hot curiosity. Of course, even today, philosophers might argue we are only in the earliest stages of understanding the universe. But if you ask an astronomer, they'll likely beam with pride at how far we've come. Behind every gleaming satellite or probe is a global team of engineers, scientists, and explorers working in unison to decode the heavens. These quiet revolutions often pass unnoticed by the public, but they are seismic in their impact. They represent turning points in the story of our species. That story is now being written by the James Webb Space Telescope, a triumph of decades-long effort, international collaboration, and tireless human ambition. It follows in the footsteps of Hubble, Voyager, and Apollo, but it looks farther, sees deeper, and reaches into epochs that existed before Earth even formed. Its mission is as bold as it is profound: to find the first lights of the universe, to explore how galaxies form and evolve, to observe the births of stars and planets, and to search for signs of life across planetary systems. And in its search, JWST has zeroed in on planets like Proxima B. This exoplanet belongs to a unique class called super-Earths, rocky worlds larger than our own, but not as massive as Neptune or Uranus. It orbits its host star every 11.2 Earth days, an incredibly fast year by our standards. Its host star, Proxima Centauri, is what astronomers call an M-type star, or red dwarf. Red dwarfs are the most common stars in our galaxy, though they burn, far cooler and dimmer than our Sun. Proxima Centauri emits just 0.16% of the Sun's total energy, and in the visible light spectrum it's even dimmer, at only 0.056% of the Sun's output. Because of their low brightness, red dwarfs are tricky to study with conventional methods, but their abundance makes them prime targets in the search for alien worlds. Most of the 5,653 confirmed exoplanets, as of April 2024, orbit M-type stars. Proxima B, orbiting just 0.04856 astronomical units from its star, receives enough energy to suggest it could have a temperate climate, if conditions are just right. The discovery of Proxima B in 2016 was a game-changer. Not only is it the closest known exoplanet to Earth, but it also sparked a flurry of interest across the scientific world. It sits in the Alpha Centauri system, which includes two other stars, Alpha Centauri A and B. Together, this trio forms one of the most fascinating star systems in the sky. And because it's so close, just 4.2 light-years away, it remains one of the most compelling destinations in our ongoing mission to explore the stars. What truly captivates astronomers is Proxima B's location within its star's habitable zone. This raises tantalizing possibilities: oceans, atmospheres, maybe even life. It's this potential that drives missions like JWST, and it's what keeps the dream alive for projects like SETI, the search for extraterrestrial intelligence. SETI is often likened to a galactic treasure hunt, where instead of hunting for gold, we're scanning for radio waves, light pulses, or strange patterns in data, any signal that might suggest we're not the only ones out here. And if that signal ever comes, whether it's artificial light from a distant planet or an engineered pulse in radio waves, it would change everything. It would force us to reevaluate our past, our beliefs, and most importantly, our future. Until then, the James Webb Space Telescope continues to scan the skies, methodically and patiently, like a sentinel watching over the great ocean of stars. So here we are, in our golden years, watching history unfold not on the ground, but in the heavens. It's a strange and beautiful thing to have grown up during the space race, watched men walk on the moon, and now to live in a time when we may finally discover we're not alone. The stars we once admired with wonder may soon answer back. And when they do, it won't be just a new chapter. It will be a new beginning,